So our next talk is about a critical issue in the world of federated learning, and that is about datasets. I can think of no better person to talk about what we can do in terms of advancing federated datasets than my colleague Adam. So over to Adam.
Hello, everyone. Let's talk about the data in federated learning. It's an essential part, and typically we see it naturally distributed. But we are talking about the research, therefore we need to partition data set. We might encounter two different types of data set, either with naturally existing ID, identifying, for example, a speaker or a machine, or we'll need to completely partition the data set that does not have a notion of an object. That process is typically time-consuming. We do not have libraries, that would allow to do that in a seamless way or without copying the code. And we heard many people struggling with that process, especially beginners. But yes, to better understand it, we might have a look at the data preparation workflow. So you would find the library that has the data set in a centralized way. You'll download it via the library, or if you didn't find the library, maybe you need to have a manual download, figure out the partitioning scheme by going through the papers and trying to figure out the details yourself, implement it, partition the data set, and then if you're lucky, you'll also have some time for testing. Oh, I see, it was a joke. Problems with custom code. Well, we have actually some problems. It's time-consuming. It might lead to limited adoption of your work, and it's error-prone. That's for the creator. Then we have the reader. For the reader, it might be hard to understand, hard to extend, hard to reproduce. It's framework specific and it has limited documentation. That all makes that process for both creator and reader quite a challenge. The solution, I'm happy to announce Flower Datasets. That's the library that allows you to seamlessly download, partition, and do any kind of pre-processing for federated learning that you'll need. It solves the problems that I mentioned, and I want to go one by one and tell you how. Firstly, that's the whole code you need to partition the data set, and in that example, I'm using Dirichlet partitioner. We have two abstractions, and I'll talk in more details about them. It won't be time-consuming when using Flower datasets. It's hard to understand, and the custom code. Let's understand how Flower datasets works. We have two abstractions, federated dataset and partitioner. Here's how you create federated dataset. You have the dataset, give the dataset name, and you specify partitioners. Then you're ready to go by doing just load partition and giving the partition an ID or loading the full split. Some of the things I'll clarify in more details later, so no, don't worry. And we have partitioner. Partitioner is an abstraction that, as the name suggests, does exactly the partitioning, and it's customizable, and we provide many of that abstraction. So federated dataset will take partitioners in a specific format and download the dataset and do all the steps that you will need for your experiments. And I'll talk in more details about it. Hard to extend? Yeah, so let's do some basic math. In order to determine how many datasets, how many federated datasets we can create, let's just loop over all the partitioners that we provide. Each partitioner might come with suitable, accessible dataset. So suitable if you want to use natural ID partitioner, but you use dataset without the ID, of course we cannot count it. And so that's the suitable. And accessible is the part, well, the library allows you for limited number, typically, of data sets, and we have configurations. So each of such partitioner can be configured in a specific manner. You can have the alpha parameters, number of partitions, partition sizes, and things like that. So if we have same API for dataset to make it, for the library to make it understandable, we can have all the datasets downloaded easily. So let's see how we can, how we go for that number, how we derive it. Here is just the name that you pass. And if you're going from, for example, NIST to Cypher 10 or whatever, that's the whole difference when it comes to the data set. And Flower Labs uses Hugging Face under the hood. So you go to Hugging Face, go to the data sets, you type in the name of the data set, and you might find that there are over 100,000 data sets available there. You pass that name there, and you're ready to go. So here is an example of NIST. You copy that little thing, the name that you find in the orange box, and you also have the preview of the dataset on their website if you want to check it out prior to doing your experiments. Partitioners part, right? How do we go with that number high? We allow each federated dataset to have multiple partitioners, and we pass it as split to partitioner. Let me explain in more details. Partitioner, you'll create it, instantiate it out of many out-of-the-box partitioners that we have, or create your custom one. And you'll give a configuration, just like, for example, train split will be partitioned according to the partitioner that you just instantiated. Then you just go load partition, give partition ID, you're ready to go. That's the part that will change. IID, shard, Dirichlet, and many others. Oh, natural ID, yeah, if a dataset allows you. Well, flexibility. Let's talk about more the configuration of the dataset. Dataset comes often with some predefined splits. That's how they are also represented in Hugging Face. You might typically find dataset with train and test split. That's the division that was created typically for centralized machine learning. What we allow you to do is, if you want, you can just go and you can also grab one of that splits for example, centralized evaluation. What you can do is you can also resplit the data set. So train test to your new train test that, for example, contains 60-40 instead of 80-20% of the data. It's up to you. Well, let's say you want to partition the train part of the data set. What do? Yeah, you pick it and you assign the partitioner. A little bit of notation that will be useful later. Each partition can be further divided. For example, if you have on-edge train and on-edge test, for example, we will call that thing divisions. And we also provide functionality, coming back to the centralized thing. For example, if you want to create a centralized data set out of the test, let's call them, or evaluation parts of the data set of each of the partition that you create. You can also do that thing quite easily, just one line of code. So you choose, for example, in that case, if I specify the list 80-20, then if I pick the division ID 1, it will correspond to that little thing that is that has orange box around it. So we have the centralized dataset creation also enabled. Just coming back maybe, partitioner, you'll create, for example, train, and you create a Dirichlet partitioner to partition the train split of the dataset. What you can then do, you're not limited to using a single one. For example, if you plan to use only certain devices for training and other for evaluation, not splitting the dataset on each partition, but making, for example, sure that only certain clients are used only for test and other for training, you can do it too by creating a dictionary that maps many of the splits that you create or resplit and create and allows you to partition it also according to, you might choose different partitioning schemes. Here we go, framework specific, and that also goes with limited adoption. And it's definitely not the case because you might create your new partitioner by simply subclassing the partitioner abstraction unit, load partition basically method, and you create the indices or whatever you need in your custom way. It seamlessly integrates with the whole federated data set, and regardless of the type, modularity of the data that you'll choose. And it's open source, so whenever you create your work, you can also create a pull request and have that in our library and let other people enjoy it too. Well, we go framework specific. So typically what you'll find is once you download it and partition, it's, for example, if you're a PyTorch fan, you'll do it in PyTorch, NumPy. Here we allow you to use any of the following. So TensorFlow, PyTorch, JAX, Hugging Face, NumPy, Pandas. It comes by default with Hugging Face dataset, and yeah, that's the abstraction on which the partitioning happens. But it allows you to use your work across different frameworks. And it's important because we have the same data source regardless of the ML framework of your choice. Therefore, it makes your work also easier. No need to create the same thing, but to just use different framework. Yeah, so let me back it up. Here is how you do it to transform to TensorFlow dataset, one-liner. It integrates with TensorFlow transforms. Here is how you can do it. NumPy, one line. Pandas, one line. Well, that was framework specific. Hard to reproduce. We have the seed mechanism that makes sure that order or any kind of operation that is random, you have full control over. Well, limited documentation. You're welcome to check the documentation on Flower AI, Flower Datasets. Error prone, it's throughoutly tested, so you have unit integration test and constant GitHub CI, so you might be sure that, you can be sure that the data set, that it works what it does. Well, yeah, the time ends up. I'm Adam Narożniak, I'm a data scientist at Flower Labs, and here is how you can download the library, pip install Flower Datasets, Vision, Audio, or without the thing for any CSV or any other thing that you need. Thank you, and yeah, questions?
Thank you for the talk. We'll take one quick question from the audience, because that was pretty important material. Yeah, from this guy down here. Thank you. What's your name? Daniel. Yeah. Okay, Daniel.
Thank you.
What's your question?
Okay, thank you very much. Hello, Adam. Pretty nice job, indeed. My question is, in the future pipeline, do you consider to include also features queue and quantities queue? I mean, you are already working on labels queue properly?
Yeah, definitely, and everyone is also welcome to contribute, and we'll try to follow up also as the research follows. We'll be happy to simulate any kind of heterogeneity that someone comes up with.
Perfect. Thank you, Adam.
Thank you.